Hello students, this is Mr. Amarjyoti Nath, your physics mentor. Okay, today I am just coming live to discuss some problems aiming that NTSE exam. Especially today's topic chapter is basically refraction and refraction. I will discuss some MCQ problems. Okay, so I hope you are going to participate with the numericals. And of course, if you have any queries and doubts, okay, you can contact even our team also at expertadvicelive.com. Okay, www.expertadvicelive.com. This is the platform. Basically, this is a booking site. You can contact with all the top teachers of different coaching centers in India. Okay, so through you can get appointment to clarify your doubts and all. Okay, even you can take class also there online. Anyway, so let me discuss some problems. Okay, this is basically a basic concepts of light. Okay, reflection and refraction we are going to discuss today. So let us discuss the first problem. I hope you are going to answer it as soon as I upload it. Okay. Well, this is the first question. So please go through it. So it says an object is placed at a distance of 0.25 meter in front of a plane mirror. The distance between the object and the image will be, well, so I hope you are going to write the answer in the comment box. I am waiting for you. Well, all those attending the class on live, you can just mention your presence also in the comment box. Well, it will make the class more interactive. So what's the question? An object is placed at a distance of 0.25 meter. It is aiming for class 10 students. Okay, so you can share it with your friends also. Okay, and after the live session, once the live session over, it will be uploaded in the channel. So you can share with your friends also. So an object is placed at a distance of 0.25 meter in front of a plane mirror. The distance between the object and the image will be, well, the options are 0.25 meter, 1 meter, 0.5 meter, 0.125 meter. Well, so do comment. Okay, well, students do comment. Commenting is enabled, na? Yeah. So let me discuss it. Okay, it is basic problem on that reflection through a plane mirror only. So what is the concept behind it? Say we are having a concave mirror, or sorry, it's a plane mirror, okay. Say this is the plane mirror. Well, so in front of it, say we have one object O here, okay. So you can take thousands of rays, no problem, but only 2 rays are sufficient to draw the ray diagram, okay. Say one ray is falling normally, it means angle of incidence will be 0 only, okay. So as the angle of incidence 0, so it will also retrace its path, because angle of reflection also 0, it means reflected ray will go in this direction, okay. And take some another ray, say this ray is going in this direction, so this will be the incident angle, okay. So incident angle and reflected angle are same, so it will go away. Well, so you see this is one reflected ray, this is one reflected ray, they are diverging. as they are diverging out, so they are not going to meet anywhere really. So it means there will be no question of forming a real image. Okay, so if you extend them back, they supposed to meet at this point, na? So that is why this image is called virtual image. They are not actually meeting, they are supposed to be meeting only. So and we can prove that by geometry this triangle and this triangle are congruent. So it means the object distance is equal to what? The image distance. Well, so in the question it is given that this is 0.25 meter, and so obviously it will also be 0.25 meter only. So it means altogether the distance between object and image, okay, it will be what? Just sum of these two, 0.25 plus 0.25, so altogether 0.5 meter. Okay, you are absolutely correct. Well, C is the option. So I hope it is clear. Okay, so from that that additional information also you should gather, huh? Object distance, image distance equal, image is virtual in case of this plane mirror because object was a real object. Okay, it is a real object, so hence the image is virtual. Okay, you can learn it also. In a plane mirror, if the object is real, the image is virtual. Well, so come to this problem, second problem. Go through the question. Good. So what does the question say? The angle of incidence of a ray of light having zero refraction angle is, well, that is also a basic question. So you should not take much time in commenting. So basically the question is that if the angle of refraction is 0 degree, so what will be the angle of incidence? Well, the question is as simple as that. So please comment what is the options A, B, C, D, A, B, C, D. Well, the answer is A only. Okay. Why? You see, say this is one mirror. So first of all we need to draw a normal here. Okay, normal, always normal itself says that the angle is 90 degree only, na? Say this is the incident ray. Well, so this is the angle of incidence, and we understand that from the law of reflection, angle of incidence and angle of reflection always remain same. So if r equal to 0 degree, so I also will be what? 0 degree. It means it is falling normally only. Okay, actually the picture is the ray is falling normally and incident angle become 0 only. Okay, so angle of reflection, angle of incidence always equal. So that is why angle, that answer is what? 0 degree only. Okay, I hope you have thought like that only. So that is very important. That is part of law of reflection only. Angle of incidence equal to angle of reflection. So go through with this problem now. Read it properly. For a real image, real object, which of the following can produce a real image? Well, object is real, image also should be real. Remember, after refraction, the rays should actually meet. Okay, that is the important point. The rays should actually meet. Okay. you have to go with the ray diagram properly and you will understand it. Plane mirror, concave mirror, concave lens, and convex mirror. So, out of the following 4 options, plane mirror, concave lens, convex mirror. So, where it is possible to have a real image for a real object? Well, so out of the 4 options, A, B, C, D. Okay, you can write only the options. Okay, no problem. Yeah, answer is concave mirror. Absolutely correct. Absolutely correct. Okay. Concave mirror is actually a converging mirror. Okay, converging mirror. So, in case of plane mirror, you can learn that when an object, a real object is there. Real object means what? Which is giving out light actually. Okay. It may be a primary object or maybe a secondary source of object. Okay. So, if it is a glowing bulb, that is also a real object. If it is a ordinary, say this is the pen, the marker, okay, that is also a real object only, though it is not giving out light, but it is taking from somebody else and giving out, so light. So, those objects which are giving light, they are real object actually, and those objects which are actually, we can assume that light is coming from it. So, these are actually virtual objects. So, that will be discussed later. So, when the object is real, so image is always virtual in case of plane mirror. But in case of concave mirror, we can get a situation that say rays are coming in this way, okay, from infinity, say they are coming. So, they will meet at the focus, okay. The rays are actually meeting here, actually meeting. So, actually meeting means what? It means actually image will be formed. So, that is a real object, okay. And for concave lens, if you see, say the rays are parallel rays are coming. I am just taking one example only, okay. So, the rays will be diverged, okay. So, as they are diverged, so they are not going to meet anywhere. So, there will be no possibility of forming an image in the right side, really. But if you extend them back, they are supposed to meet at this point. So, here you can find a image, but this image is actually not real one, okay. That is virtual because they are supposed to meet exactly that way. In case of I am talking about an example of a parallel rays only. It means object is at very large distance, okay. So, in case of this also you can see the rays will be diverged, okay. After reflection it will be diverged. So, this ray and this ray will never intersect. So, there will be no possibility of forming a real image if they are supposed to meet at this point. So, here also we can get an image. So, that is why this image also virtual image only, okay. This is also virtual image, that is also virtual image, and here only we can get a real image in this case, okay. So, absolutely correct, that is a concave mirror only, okay. All those who have going through this video in delayed live, okay. So, you can also comment giving a pause to the video. Now, let us discuss this problem. Which of the following mirror is used by dentist to examine a small cavity? Concave mirror, convex mirror, plane mirror, concave mirror, combination of concave and convex. Okay, I think you will not require much time to solve it, but anyway, Go through it properly and write the answer. Go through it properly and write the answer. Okay, I will discuss only 10 problems today, but it is just a invitation to all of you. Okay, you just share with your friends, and I will come time to time. I will come like that. Gradually, day after the question also will be going on increasing. Okay. Which of the following mirror is used by a dentist to examine a small cavity? Well, yeah, answer is concave mirror only. Okay, great. The answer is concave mirror only. When actually an object is placed very close to a pole of a concave mirror, okay, this point is called pole. Say this is the focus. When the object is placed that one within the focal length, okay. So if I draw the ray diagram, na, this is the parallel rays, so it will go towards the focus. Well, so say this is going towards the pole, so equivalent angle forming an equal angle of reflection, it will go back. Okay, these two are diverging, but if you extend them back, they are supposed to meet at this point. Well, so this is the ray diagram. So this is the point AB. Okay, object AB. So B point's image is formed at here. Okay, B dash, and correspondingly A's image will be formed here. So A dash B dash is the erect and enlarged image. Okay, first of all, it is virtual. Remember, virtual image only can be seen by our naked eye. Huh? We can learn it also. Real image never be seen by naked eye. A real image can be seen by our eyes only when it is placed on a screen. Okay, but virtual image we can see easily. So it is a virtual image and erect image and enlarged image. Okay. So this technique is used by that one dentist. Actually, say this is the concave mirror used by the dentist. Okay, so he is holding it and say this is the teeth. Okay, so when it is that mirror is placed close to your teeth, na, so the holes or cavities, na, it can the image of the cavity will be found as enlarged way. Okay, so it will be quite visible for the dentist to operate it properly. Well, and hope so this type of days will never come to your life. Okay, anyway, good. This the answer is concave mirror. So let me go to the other problem next. Please try it. Good. All of you are doing well. An object at a distance of 30 centimeter from a concave mirror gets its image at the same point. Okay, the focal length of the mirror is. Well, you can use it. You can solve it using pen and page also, or if you apply some creativity, I think without pen and page also you can solve this problem. But anyway, how you are doing, that is not a main problem. We need to go to the actual answer only. Well, hope you are trying. what should be the answer? Is it minus 30 cm? Is it 30 cm? Is it minus 15 cm? Is it plus 15 cm? Because sign convention is also important, okay? Plus, minus, na? So we will discuss it in details. Well, let me discuss it, okay? So, see, first of all, let me discuss about what is sign convention, when it is positive, when it is negative, okay? So, I am going to give you one, important concept. So, this will be valid everywhere, okay? In case of lens also it will be valid, in case of mirror also it will be valid, okay? You can apply it anywhere. First of all, say this is one mirror, okay? So, if it is a mirror, na, every measurement is done from the midpoint of the mirror, okay? Say this is the principal axis, say object is here. So, see, the object distance is, if you measure from here, then also you are going to same value as you measure from here, okay? But remember, you will measure from this point only, okay, this point. And now you understand that the object gives out rays, it means rays going in this direction, na? So, if the measurement is done in opposite direction, na, so it means the quantity will be negative, okay. If the measurement is done in opposite direction of the ray, the quantity will be negative. So, it means object distance will be negative only. So, object distance say 1 millimeter, 2 millimeter, 3 millimeter, 4 millimeter, okay. So, I am measuring in opposite direction, na? Because rays are going in this direction, from the object always rays go. So, that means object will be in negative, okay. And we understand that focus is here for a concave mirror, okay. So, that means focal length also will be negative only. And we understand that double of the focal length is called radius of curvature, r equal to 2f, na. So, radius of curvature of a concave mirror also will be negative only, okay. Well, so this is the sign convention. So, as it is given that the object at a distance 30 centimeter, okay. Here in the question it is given the object is at 30 centimeter, na? So, it should be taken as negative only, object distance will be negative only, okay. So, you can apply mathematics also. If you apply the mirror formula, so 1 by V plus 1 by U equal to 1 by F. So, 1 by V we do not know. No, we know it because object and image at the same place only, na. So, directly we can put the value, image also formed at that particular distance only, okay. So, it means image also formed at minus 30, object is also formed at minus 30, well, and that is 1 by focal length. So, it is nothing but 1 by focal length is minus 2 by 30. So, f equal to minus 15 centimeter. Well, so means focal length of that particular that one mirror is minus 15 centimeter. So, minus means it is a concave, okay. Concave lens or concave mirror both have the same negative focal length, okay, negative focal length. And if you are asked to calculate the radius of curvature of the mirror also, then also you can calculate it. So, it is what, minus 30 cm. And also you should learn that when the object is placed at the center of curvature, image also placed produced at the center of curvature only, okay, for concave mirror. You can learn it also. Well, that is a common thing. Actually, from ray diagram only we can discuss it. Well, so please go through this problem. Now, an object is at a distance of plus 15 centimeter, na, is slowly moved towards the pole of a convex mirror. The image will get shortened and real, enlarged and real, enlarged and virtual, diminished and virtual. Well, you can try it. out of the 4 options, which one is correct? Well, an object at a distance of plus 15 centimeter is slowly moved towards the pole of a convex mirror. The image will get you can read it as 15 centimeter, okay, not plus 15 centimeter, otherwise it will violate that sign convention whatever we have discussed, okay. So, it is just 15 centimeter, okay, object at a distance of 15 centimeter from the mirror. Well, so that is the question. So, you have to actually know the ray diagram of that convex mirror, okay. When the that one, say this is the convex mirror, when the object is at infinity, okay. So, obviously rays will be parallel, because when rays come from infinity, now we will take that they are parallel, okay. So, it will reflect back in such a way that if you extend them, they are supposed to meet at a single point, and that single point is called focus, and which is a virtual focus only, okay, for a convex mirror. So, object is at infinity, the image is at this f, and which is virtual, okay, first of all. And when is the object is at somewhere in between, okay, infinity and the pole. If I draw this again, say the object is here, well, AB. So, if you take one parallel rays, it will go away from it, okay. In this point you can say it is a focus, well. Or if you take one another ray which is aiming towards the C, C is the center of curvature, say it is aiming towards the C only, okay. It means if you extend it, it will go to the C point, okay. Then of course it is falling normally only, because all that one radius are normal to this surface, na? So, it means this ray is falling normally, so it will bounce back. So, this is one reflected ray, this is one reflected ray. So, if you extend them, they are supposed to meet at this point, okay. That is a, again this image is a virtual image only, and which is smaller in size, smaller is called diminished. Well, again if the object is exactly on the mirror, if the object is exactly on the mirror, so image also will be exactly on the mirror only, just behind it, okay. So, it means the image is moving from F to this point, okay, image is moving this way, and when the object moves in the right way. Well, so first option is wrong, shortened and real, real is totally wrong. Enlarged and real, that is also wrong, because it is not enlarged and it is not real also. Well, C option says enlarged and virtual, virtual is true but not enlarged. D option says diminished and real, virtual. So, ultimately D option is correct, okay, good. So, come to this problem. A concave mirror of radius 30 centimeter is placed in water. Its focal length in air and water differ by, okay, that is also a very good problem, okay, that is a good problem, you please try it, okay. So, whether the focal length of a mirror is medium dependent or not, okay, that is a question basically. Well, you are doing great. A concave mirror of radius 30 centimeter is placed in water. Its focal length in air and water differ by 15 degree, 20 degree, 30 degree, 0 degree. That is the question. Well, actually you see, in case of mirror, na, only reflection, law of reflection is valid, okay. Say this is the concave mirror in air, okay, or you can say that in vacuum. Say parallel rays coming, principal axis, that one, parallel to principal axis. Say this is the center of curvature. So if I draw an line here, so this will be nothing but the radius, and which is normal also at this point, okay, because radius is always perpendicular to the tangent of the circle. So this is the incident angle. So with equal angle it will fall down, okay. So this point is nothing but the focus. So so this length is nothing but the focal length. Well, from the pole to focus it is called focal length. Now you see, if the same mirror now inserted in say water, okay, say now water is there. Obviously water refractive index is something different than that of air, okay, refractive index is different. But now you see what will happen here, if say this is the parallel axis, a principal axis, if a ray parallel to it falls, okay, so again the center of curvature will not change, na, because it is the geometrical center of the that one mirror only, na. So C will be same. So let me draw a normal here. So this is the normal, which is radius also. Now actually it will follow the law of reflection only. It means incident angle must be equal to reflected angle, na. So automatically this angle will be fixed. So focus also will be fixed only, okay. So it means focal length will not differ if it is inserted in a different medium also in case of mirrors. It may be a plane mirror, it may be a concave mirror, it may be a convex mirror, okay. So focal length will be remaining same. So what will be the answer? Answer will be 0 degree, okay, 0. There will be no change in the that one. Well, in case of lens it will be different, okay, we will discuss it if this type of problem comes, okay. But in case of that one mirror, it will not be changed. Well, so please go through it. A concave mirror of focal length 20 centimeter forms an image having twice the size of object for the virtual position of the object. The position of the object will be at. For that actually you need to know two formula. Huh? First of all, mirror formula. Mirror formula is what? 1 by V plus 1 by U equal to 1 by F. Okay. And second thing is magnification of a mirror. Okay. M equal to minus V by U, which we need to know it. Well, okay, for the timing, I think I find a small problem in the question. Okay, you can remove this part. Okay, virtual part you remove it. Simple. Okay, a concave mirror of focal length 20 centimeter forms an image having twice the size of the object. Means picture is little bit like that. This is concave mirror. this is the object and image is formed somewhere here, okay. It is like that. So what that one position of the object is what, okay, u value we need to find out. Try it, okay. You have to have some calculations of course in this problem. Okay. In this problem you see magnification is double, okay. So we know that m equal to what, by definition only, okay, minus v by u. So m is double, so it means minus v by u. So it means v equal to what, minus 2u, okay. It means if it is something x, so it will be 2x, okay. So now you put it in the formula, mirror formula, 1 by v plus 1 by u equal to 1 by f, 1 by v is minus 2u, u we do not know the value of u, okay, and focal length is what, concave, na? So it is minus 20 only. So I think you have to just solve it, okay, take the LCM and all and you solve it, you are going to get u equal to minus 10. It means object distance should be minus 10, image distance will be minus 20, like that. Well, actually image will not be formed in this side, okay. Image will be formed in this side only, because object, you see object will be that one less than that one focal length, na? So it means image will be in this side only, okay. This is the object and this will be the image. So ray diagram will be like that only, okay. Because object is within the focal length, na? So image will be real, virtual and enlarged, 2 times enlarged, na? They have already given, okay. So I think in the question that virtual they are going to, actually object is not virtual, actually image is virtual, okay. So I think there is a little problem in the question. Anyway, you should understand it, okay. Automatically if you get u equal to minus 10, so you should understand that it is the less than the focal length. So automatically image will be on the right side of the mirror only, which will be virtual and enlarged, okay. We have already discussed also these things. Well, so go with the next problem. The image formed by a concave mirror is real, inverted and same size as that of the object. The position of the object should be at the focus, at the center of curvature, between focus and center of curvature, beyond the center of curvature, okay. Direct question. So from the concept of ray diagram only we can understand this. Well, the image formed by concave mirror is real. Real means what? If it is concave mirror, so image should be also in the left side only, okay. Inverted and in the same size. So it is F, it is C. So it is possible only when the object is at the C, okay. When the object is at the C, center of curvature, the image is also formed at the C only. That is real, same size, well, and inverted. So answer should be what? At the center of curvature only, okay, in this question. So come to the last question. of today's class. Okay, it is just a invitation class only. Okay, not a regular class. So you can for any queries you can write in the comment box. Okay, those who have seen the video, and of course giving a pause to the question, you can just try it first. The nature of the image formed by a concave mirror when the object is placed between focus and the center of curvature of the mirror observed by us is. So you please try it. I am helping you drawing the diagram. Pole F C. Object is placed between focus and center of curvature. Well, say this is the object A, this is B. So draw, okay, from B take a parallel line. So it will definitely go towards the focus. Well, so if a second line is taken towards the focus, okay, so it will definitely go parallel. So this will be the image, okay. So this is the point A, so this point will be A dash. If this is the point B, this point will be B dash. Well, so first of all it is real, na, because rays are really meeting, na, really meeting. So real and seems to be enlarged also, okay, inverted also. Well, and beyond C, okay, beyond C. If the object is between C and F, the image will be formed beyond C, because when the object is at C, image is formed at C. When object goes close to the mirror, image goes away from the mirror, okay, that is the thing we should learn also. So it is beyond C, okay. It means you can say that image distance is greater than radius of curvature. Well, so out of the 4 options, which one will be correct? I think C will be the fit. C will fit best, na? Real, inverted, and enlarged. Okay. First option says real, inverted, diminished. So it is wrong. Virtual, it is wrong. Virtual, it is wrong. So C is the best answer. Okay. Well. So guys, this is just a trailer only. Okay. Today, just we have discussed only 10 problems. We have a lot of questions in our year. Okay. So you can try it and you come and join us regularly, okay, and keep commenting, okay, whatever is required. So say this is the question number, that is another question you can take as homework, okay. This is a question you can take as homework. Just take a that one screenshot, okay, and also please its answer. You can take this problem also, okay. Take a snapshot of this, try it, or you can give a pause to the video, try it, and write the answer in comment box. Exactly this problem also, okay. And one more problem I am going to give you altogether, okay. So take it, give a pause to the video, do it, and write in the comment box. And finally this, okay, 15. Well guys, nice meeting you, and hoping soon we are going to meet again, okay. Thank you. Bye bye. Bye bye.